Bismillahirrahmanirrahim. In this video, Bismillahirrahmanirrahim. In this video, I'll be constructing a portfolio out of five assets. Right. I got the stock returns from Karachi Stock Exchange, and we'll be constructing first of all two asset portfolio and the derivation of the two asset portfolio. Then I'll be constructing a five asset portfolio on Excel. Then I'll be using two front theorem. So practically I'll be driving the mechanics of portfolio. Then I'll be using solver to construct a minimum variance portfolio, and thereafter I'll be using two fund theorem to construct efficient portfolio. So these three steps I'll be using. So starting on first with the portfolio return and portfolio variance. Let's say we have two assets and whose returns are presented by R1 and R2 with respect to weights W1 and W2, and some variance sigma 1 square, sigma 2 square, and sigma 1 2 with the covariance. Then the asset return is the portfolio return is given as W1 R1 plus W2 R2, and portfolio variance is given by W1 square sigma 1 square plus W2 square sigma 2 square plus 2 W1 W2 sigma 1 2. Now this problem seems straightforward when we have two assets, but when we get multiple assets, more than two, these equations get complicated to do manually, so we have to use software with that. So in the example, I'll be using five assets. So generalizing it to the n assets, we have we can represent the n asset portfolio as return as summation W I Ri, and portfolio variance as summation Wi J sigma I J. This is portfolio variance. So in order to get the whole thing done, we will use matrices to solve the whole situation. And first of all, I will do I will use the solver. Then I will use the two front theorem. So I'll get back to this situation when we done with the minimum variance portfolio. Right. So these are the prices of the last 5 years, monthly closing prices of 5 assets: Honda, Unilever, Asgard, Angro, and Glaxo. First of all, we're using I'll be calculating returns of these assets. I'll be computing log returns, make it in continuous compounding. Compute the average return. And for some reason, I'm gonna copy paste as value. Right. So next is I want to calculate variance covariance matrix. I'll use covariance, select my input range. Labels in the first row. This is variance covariance matrix. Wanna fill that up. I don't want that. I don't need that. Let's put 0.5 here. Vector of ones. Make sure this all adds up to 1. It is not 1, but don't worry about that. Transpose of weights. Weight again. So these are the actually return and risk of the portfolio with these weights, but we are violating one condition, that our wealth is exceeding 100%. So solve this situation with the help of solver, where my target cell is this. I want to get this minimum. I want to let the solver change these things, and I have a constraint that, okay, and I have a constraint that this thing should be equal to 1. Press OK, and let this solver found a solution which is 64% wealth in Ango and 0% in Honda. I can put change of this thing. I can put additional constraints such as don't put any major amount on it, maybe less than, let's say, 20%. And in this asset, I want to put more than, let's say, 15%. So solver font solution again. So my desired portfolio is here with the minimum variance. Return is negative, doesn't mind. So this is the situation, straightforward, when I get to choose my desired portfolio. But if this things doesn't happen, so if I'm a fund manager, what banks does, what mutual fund companies does, they construct two portfolios and they construct sweep out a whole series of portfolios from these two portfolios. So how we do this? So we know that portfolio return is given by this equation, portfolio variance is given by this condition, and we have a constraint that summation of weight should be 1. So we develop a Lagrange multiplier. The equations for this Lagrange multiplier would be summation Wi j sigma I j plus some lambda, and I will be using this equation summation Wi Ri minus Rp minus some other mu, another Lagrange multiplier using this equation summation W minus 1. So this is my first equation. My second equation, obviously, Wr is equal to Rp, and my second equation is summation W is equal to 1. So these are, if these are n assets, then these are actually n plus 2 unknowns, n w's and 1 lambda and 1 mu, and n plus 2 equations. So we have n plus 2 equations and n plus 2 unknowns. To get these things, we can differentiate with respect to w's. Ultimately we'll get the thing after differentiating as summation W j sigma I j minus, this is minus actually, minus lambda r minus mu. So this is after differentiating, you will get these set of equations, and obviously our original equations W equal to 1 and Wr is equal to Rp. So solve for lambda and mu simultaneously. How we can do this? In this equation, Wj sigma Ij minus lambda mu, portfolio mu minus mu. We can solve, find the values of these w's and ij's with different weights of the our two fund portfolio as two portfolios as by first putting lambda is equal to 1, mu is equal to 0, and then lambda is equal to 0 and mu is equal to 1. If I put these two things, then I'll get two sets of w's. I can name it W1 and from this W2. Now these two weights should equally be adding to 1, but if that doesn't happen, which will not, we will normalize our vector of weights 1 and 2 in such a way that they add up to 1. So rest of the things I'll do in Excel so you can understand the things what I'm saying. Secondly, after getting appropriate weights which add up to 1, we will construct and sweep out, the word sweep out, a whole set of efficient frontier. This is a part of the portfolio theory. Um, if alpha belongs to minus infinity to infinity, then we can construct an efficient portfolio using this equation, w alpha plus 1 minus w into 1 minus alpha, right? So let's see how we do this in Excel. W1, W2, first multiply with R, then M inverse, okay, these two equations which are about M inverse and multiply with R, then M inverse of my variance covariance matrix multiply with ones has come up by putting these things, lambda is equal to 1, mu is equal to 0, lambda is equal to 0, mu is equal to 1. I can give you a separate derivation of these things if you want. So let's see if they add up to 1. They doesn't not. So we can normalize these things as let's say v1 and v2 in such a way that this thing should be divided by sum of this, and this thing should be divided by sum of this, right? So let's see if we tap to 1. It's thus same as with now we should construct how many portfolios? Let's say we can construct 40 portfolios starting alpha from minus 20, minus 19, gone too far, right? So how we're gonna do this is remember the alpha weight into 1 minus alpha weight kind of thing. So this alpha multiply by v1 plus 1 minus this thing multiply by this, okay. I want this thing locked, want this thing locked, want this thing locked, and this thing locked. Make sure if add to 1 or not, double check. It does. Same with other things, yes. So these are the weights of 41 portfolios So we calculate risk for each same matrix multiplication. Bracket close, comma. Right. Okay, why it does not solve? We fix that later on. Calculate the return. Actually, you don't want that transpose. Original returns. What's the problem with this? Actually, I didn't lock these cells. Okay, and I should also lock these cells as F4 and F4, right? Because that's the matrix. So Control Shift Enter. That's the matrix. Control Shift Enter. Copy that. Okay, why? Okay. Don't worry. I got this right, maybe. Right. So these are the risk and return of my 41 portfolios. Let's see if it works or not. Right. So you can see here a complete set of efficient frontier in this. So investor can opt to invest any portfolio along this frontier, and this is the minimum variance portfolio. And practically, what fund managers does, fund manager don't need to do multiple selection of portfolios, multiple assets in the portfolio. What he does is construct simply two or three portfolios in this manner, two or three set of these two asset portfolios. Then, for example, is low risk portfolio, high risk portfolio, medium risk portfolio, portfolio constructed out of stocks, portfolio constructed out of bonds. Then, as per the risk appetite of the investor, fund manager, or as per the management risk appetite, fund manager can take and as many as portfolios out of these things, and taking at the same time with the efficient frontier.